Today, we're diving into one of the most expensive and honestly kind of embarrassing math mistakes in history. And we're going to look at the surprisingly simple tool that could have prevented the whole disaster. Okay, picture this. It's September 23rd, 1999. NASA is guiding its Mars Climate Orbiter, this incredible piece of technology, into orbit around Mars. Years of work, hundreds of people, all leading up to this moment. And then nothing. Just silence. The spacecraft was just gone. And we're not just talking about a scientific loss here. This was a financial catastrophe. The mission cost a jaw-dropping $125 million. All of that brain power, all that work, all that money, poof, vanished. The big question was, how? So naturally, investigators started scrambling. Was it sabotage? Some kind of catastrophic hardware failure? Well, the answer turned out to be way simpler, and in a way, so much more shocking. I mean, think about it. The probe launched almost a full year earlier. It traveled hundreds of millions of miles through the vacuum of space. Totally fine. Everything looked perfect, right up until those last few critical moments before it was supposed to slip into orbit. So what on earth went wrong right at the finish line? The investigation uncovered something incredible. The failure wasn't a big, complex mechanical problem. No, it was a simple communication error. Basically, a failure to translate between two different languages of measurement. And here it is. This is the whole problem right here. You had two teams. One piece of software from one team was calculating the thruster force using the English system, pound for seconds. But the navigation software, built by another team, was expecting those numbers in the metric system, in Newton seconds. Nobody converted it. Because of that tiny, tiny mismatch, every single course correction the spacecraft made was wrong. The computer thought it was making these tiny, delicate adjustments, when in reality, it was giving the thrusters way too much juice. So instead of gracefully entering orbit, the probe flew way too close to the planet and was either completely destroyed by the atmosphere or just slingshotted out into deep space forever. So here's the kicker. This entire $125 million disaster was completely preventable. The solution is a basic math tool that you probably learned in school. It's called the conversion factor method. Let's take a look at how it works. A conversion factor sounds fancy, but it's really just a fraction that shows how two different units are related. Like 1 kilometer equals 1,000 meters, or 60 seconds equals a minute. You use this ratio to flip a measurement from one unit to another without actually changing its value. And the process is so simple, it's beautiful. First, you just figure out what unit you have and what unit you want. Step 2, you find the conversion factor that connects them. And finally, you multiply. The real magic trick is setting up the fraction so the units you don't want anymore just cancel themselves out. All right, let's do a really quick, simple one together. Say we want to convert 80 meters into kilometers. Okay, so we have meters, we want kilometers. And we know the relationship 1 kilometer is 1,000 meters. So we take our 80 meters and we multiply it by our conversion factor, which we write as a fraction. Now, this is the most important part. See how we put the 1,000 meters on the bottom in the denominator? We do that specifically so the meters unit can cancel out. And just like that, the m for meters on top cancels out the m on the bottom. The only unit left standing is kilometers, which is exactly what we wanted. A little quick division, 80 divided by 1,000, and we get our answer, 0.80 kilometers. It's simple, it's clean, and it's basically error-proof if you just follow the steps. Okay, so let's level up a little bit. What happens when you have units that are a bit more complex, like speed? Distance over time. Well, it just means you have to do more than one conversion. Here's a classic problem you might see. Let's say a car has an average speed of half a mile per minute, but we need to know that speed in meters per second. So now we've got two jobs to do. We have to convert miles to meters, and we have to convert minutes to seconds. The cool part is we can just chain these conversions together. So first things first, let's get rid of miles. We multiply by the conversion factor for miles to meters. Notice again, we put 1 mile on the bottom so it cancels out the mi in our original speed. Now for the time part. Our original unit has minutes on the bottom in the denominator. So to get rid of it, our next conversion factor needs to have minutes on the top. So we multiply by 1 minute over 60 seconds. And this quote from the source material really just says it all. The whole point of this method is to give you a visual check. If your units are canceling out correctly, miles with miles, minutes with minutes, you can be pretty confident you set up the problem correctly. So once you run the numbers, 0.50 times 1609, and then divide all that by 60, you get your final answer. Half a mile per minute is the same as 13 meters per second. Okay, but what happens when things get really weird? Like when you're dealing with units that are squared or cubed, like for calculating area or volume. The same rules apply, you just have to be a little more careful. This is the key insight right here. Units aren't just labels. They behave just like variables in algebra. So if you have something like square centimeters, or cm squared, that's really cm times cm. To get rid of it, you have to cancel out centimeters twice. Think about converting density, right? Grams per cubic centimeter to kilograms per cubic meter. For the volume part, you're dealing with centimeters cubed. That's centimeters times centimeters times centimeters. So to convert that to meters cubed, you have to apply that centimeter to meter conversion factor 3 separate times, once for each dimension. So let's bring it all back to that poor Mars orbiter. What's the big lesson here? Well, it's about a lot more than just math, right? It's really about the incredible, mind-blowing power of paying attention to the little things. So the takeaways are pretty powerful. A tiny little error in unit conversion costs a fortune and years of work. But there's a simple, reliable system, the conversion factor method, that can prevent these mistakes. And it all boils down to that one simple visual check, making sure your units cancel out. It's just a massive reminder that in science, engineering, and probably in life, the smallest details can have the absolute biggest consequences. It really makes you think, doesn't it? What are the small, seemingly insignificant details in your world, in your work, that could actually have monumental consequences? Thanks for watching.